Hello and welcome back to another video. In the last video, we did some programming on SCL, where I introduced you to SCL. In this video, we would like to do a short project, which I explained in some videos earlier. Let me just quickly explain that. So we have an orange man who has two sensors in his house. He has an external sensor which checks when he comes home. He has a switch which determines if the process in his house, the automation in his house runs automatically or off. In this case, it's off. He also has a door which is then opened based on automatic situations. He has an internal sensor and then he has a light bulb. So Mr. Orange comes home, he switches the system to auto so everything can work in an automatic way. When he does that, the sensor outside his house then senses that Mr. Orange is home. That sensor opens up the door. Mr. Orange goes into his door. The sensor inside the house senses Mr. Orange, right? And the sensor outside the house goes off. The sensor inside his house then closes the door, and 5 seconds later, it switches on the light. With that, when the light is on, Mr. Orange goes in. The light goes, the sensor goes off because of course Mr. Orange is no longer there. The sensor outside is also off. In this short program, we identified our input and outputs, right? And we also identified some addresses that we needed to use. This might change, but basically these are the sensors, the inputs and output that we've identified for this project. We have the sensor one, outside sensor, which is an input to the PLC. So we put address 1.0. Sensor 2 is also an input to the PLC, address 1.1. Sensor 3 is the auto switch, which is also an input to the PLC. And then we have the K1, which is an output from the PLC to open the door. Probably there is a solenoid valve, there is a mechanical device that physically opens the door. And then we have the K2, which is the light, basically maybe a relay or a switch that then turns on the light. Now we can go ahead to create a function block. In this case, I want to create a function block that does the job that we want to do. So right here, I'll click on a function block and I'll use ladder logic because we've established in the past video that when you set up your block in ladder logic, ladder language, then you'll have the capability to run ladder languages and also SCL or STL inside the block. So I'll just call this block Orange Home. So this is the block that works for Mr. Orange. Now, when we create a function block, right, it automatically, when we run it, it would create a data block. But let us start. So I'll pull this somewhere here in this screen. I can maximize this so we can see what we want to do, and then somehow let me also, yes, let me bring this to the side. We'll just manage the space. Okay, good. So the first thing we want to do is we have an output, we have an input. So we have to declare all our variables, right? And we have to go to interface to set all of that. So first we have an input to this guy, which should be the output sensor. We can call it, in this case, we call it S1. And the data type is Boolean. Here we need to put the comments if we wish to. Boolean, correct. Comments is outside sensor. Good. We have the S2, right? We have, I can declare one more, S3. Yes, and then we have all our outputs. Our output in this case is K1 and K2. K2. All Boolean in this case. We also have a timer, right? We have a timer. I won't declare that yet. So we have outside sensor, inside sensor. We have the auto switch. And then we have our door as the output. We have our light. Yes. Now we need to program all of this. So what's the scenario? We said number one, the everything that starts this process is the auto switch has to be on, right? So we put the auto switch first. So when the auto switch is on, then every other thing can run. When the auto switch is off, nothing works. So we have to set our auto switch on first. After setting the auto switch, then the outside sensor has to sense Mr. Yellow that is home. So here we also put outside sensor. So outside sensor checks that Mr. Orange has arrived home, right? And then it opens the door automatically. We didn't put any timer there. So basically this sensor has to be close to the door. Mr. Sensor gets close to the door and the door opens. So what do we want to do? We want to set an output here, right? Yes. So now we have our first entry. It works. We set our system to auto. Mr. Orange goes to the sensor sees Mr. Orange, and then it opens the door. Now we also said when Mr. Orange gets inside the house and this light, this sensor senses Mr. Orange, then the door should close. So basically this sensor is a bit far away from the door in this case, and the door should close, right? So in this case, we can do, let me put another network, right? And we said when this guy senses Mr. Orange, then what should it do? It should close the door. So what does it mean? It means it has to reset. It has to reset the door. In this case, we can use the set and reset. The set and reset. However, this switch, this inside switch, is not dependent on the outside switch. It functions basically only on the auto switch. The place I have put this network now is dependent on the S1. This S1. However, it shouldn't. So this guy is actually supposed to be here. You understand? So when the system is on auto and this sensor senses Mr. Orange, it expects, of course, that Mr. Orange is in the house. It doesn't care about the sensor. Mr. Orange is in the house. The only thing the sensor cares about is the door. So when the system is in auto and it senses Mr. Orange, so now we have the inside sensor which senses Mr. Orange, and what should it do? It should actually close the door. It should reset this same contact. So how do we do that? We change this to a set, see, a set, and then we create a reset here. So we want to reset the same door, which is K1. So when you double click on this, it gives you options that you can use, see? So we set and then we can reset. There is also another function that you see here, which is this coil and this one. So this is also similar. Let me put my button there. Okay, this just shows you the address. So you can press F1. I was trying to show you this some time ago, so I'll press it now, and hopefully it opens up, and then I can show you later. But basically, let us use the set and the reset, right? I'll change this back to the set. Set and reset. So this is clear. The system is on auto. The outside switch sees Mr. Orange. It sets the coil of the door opens. The system is on auto. The internal switch, the internal sensor sees Mr. Orange. It resets this coil. Is it clear now? Yes. So, how do we then switch on the lights, right? When this sensor sees Mr. Orange after 5 seconds is what we said, right? So in this case, we can add another network here, because when this sensor sees Mr. Orange, it's closing the door, and then it also starts the timer. In this case, we can then introduce a timer here. So in your instruction table, which I showed you in the last class, here now we can introduce a timer. So I go to timer operation, and what we want is an on delay. We want to switch something on, but we have a delay, right? So I'll say we'll go to generate on delay. I can drag this directly to this point, right? And the on delay will create its own mini block, right? I can allow it to do that. Yes, I'll show you some other instances later. So it will create its own timer. Let me just call it orange timer for now, because the block needs some timing, right? Okay, so when you click on this guy and you want to understand what this block does, again you click on your F1, right, to understand what it does. I'm trying to open the TIA app viewer right now to see if that works. However, you can also hover on top of this and it would show you what it's expecting. In this case, you see I see time, double word, double integer. So here now it's asking you to connect something that has this data type. Good. So this has opened up. Let me show you. So when you click on F1, this is what it opens. So it's saying for S7 1200, S7 1500. Basically what we're using there is S7 1500. And this will give you explanation on how the block works. There is a lot of things you can read here, quite a lot. See, different operations, timer, generate off delay. Basically any instruction that you can use inside the PLC. Once you click on F1, then you get a note here. It also tells you what you expect to put to connect on each pin of the block. It says on the PT, the value of the PT is written to the PT parameter instance when the edge changes at the in input, and then Q and ET output. So the actual values of the Q and ET are updated in the following cases: when the instruction is called, if the ET or Q outputs are interconnected, or at an access to Q or ET. Now, here, if you read, it tells you this generate an on delay instruction, right? Basically, you need to read all of this. There are also some graphical things here to explain. In this case, this is what we want to do. In this case, we set an input, right? And in that input, we want to put a delay, PT. So this is the PT delay. The PT delay delays how long the timer would wait before it then switches on an output. You understand? In some cases, you want to define it as a slope, but that's a different thing entirely. So it's showing you how you basically would run this. The tag start, which is the in, where you connect whatever you want to use to transition the block, the timer block, from 0 to 1. You have your PT, which is the preset time. So usually this is the kind of format you would give it to say this is how long you should wait before you generate an output. And then in this case, they've declared 10 seconds. You see, there is a format. This is IEC format for timing on the PLC. With this 10 seconds, after 10 seconds, then the queue is set to true. Whatever you put here will then be set to true. And here it shows time elapsed. It will show you from 0 to 10 how the time is elapsing. So you can also check this on the DB. Now I'll just copy this format, right? I'll go into our program and then I'll put this here. So now I'm coding this directly. However, what we want is 5 seconds, not 10 seconds. And what should be our output? Our output based on our project is the lights. After 5 seconds, the light should come on. And the light in this case is what? Q2. So I'll put a coil here. I can also use a set, but I'll just put the coil here, and that's our K2. Good. So this is Orange Man home. I'll compile, see if we can simulate this. It compiled. Let me run a simulation. Save the project and simulate this. Hey, I'm just trying to download the code onto the PLC simulation. We've already gone through this process in our former videos, so you can also see that. So right here, we're connected to our PLC. Our simulation seemed to be running. Now it's running. I just set it to run. It's still blinking, not completely done. So it's still loading somehow. When this is done, the light should stay green. Let's see from our code in itself. Let me go online. To check what we have. I haven't called this block yet. I haven't called it in the OB1. So it's currently in the PLC, but it's not inside the PLC cycle. So the PLC is not processing this program yet. It's until we call it inside our organization block before this code would run, right? Okay, so it looks like our PLC is running because we can go online. I see a lot of greens. Yeah, it looks like our PLC is running, which is good. However, you can see everything here is just gray. Now I have to call this block inside the OB1, so I'll open the OB1 network. Let me minimize this. Yes. So no, this is our FC1. I want the OB1. Yes, this is our OB1. Now I'll call our Orange Man home block, which we created inside OB1. And this is Orange home. I'll just drag it inside OB1. Now when I put it in OB1, that's when I expect the PLC to program it. Now you see what happens. It's trying to create a DB because a function block has a database comes with a database. It needs to store all of this data that we've declared inside a database directly. That's one of the differences between a function block and a function call. You can see even the colors are different here. FBFC. So we will also check the differences between both later, but I wanted to show you this. So I called the block, I pulled it into an OB1. I'm instantiating an instance of it. I'm instantiating it, and then it's creating a data block. Because you can use this function many times, of course. So I'll call it Orange Home DB, a data block in this case. It will then create the data block. Now this data block is instance data block. It's not a global data block, which means I cannot edit it. Whatever I code in my function block is what the DB would have. Let me just quickly double click on it so that you can see it as well. So you see whatever I have inside my function block is what I have in my DB. So I'm programming here, but all of this data need to be stored in the DB so I can monitor it. I cannot come here and say add whatever. I cannot do that. I'm right clicking it. I cannot insert. I cannot do whatever. I cannot edit this because this DB is locked on to this block, this function block. However, in my global DBs, which I created, I can add things. I can see if I right click, I can insert, I can add, I can do whatever I want to that. It's a global DB. Anybody can use it. But the instance DB, nobody can use it apart from this function block, right? So we have our block being called in here, and we need to now put our input and outputs, whatever. I'll go back here and see what we declared. So we had 1.0, 1.1, 1.2. So here we had Q 1.0, Q 1.1, and then Q 1.2. Q 1.2. I don't know if we've defined this text correctly, but right now I'm just following what I have defined here. So let me see. No, it's not. See, this is outside sensor, inside sensor, auto switch. For now, I don't really care. I just want this to run, and then I'll change the namings properly later. So we have the Q 1.0, Q 1.1, Q 1.0, Q 1.1. Okay, fine. Light, relay light. No, 0, no, no, no. 1.0, no, this should be I. I use Q here. Yeah, this is where I know I'm wrong. This is I 1.0. This is input outside sensor, correct? So basically it looks like we did declare it properly. Inside sensor, correct? And then we have 1.2 switch auto. Good. It looks like we've done everything properly, right? I'll save this. I'll compile, and then I can download it. And then I can download to the PLC. Let the PLC now process it. We have a lot of orange and blue because what we have offline is different from what we have online. Now when I download it to the PLC, everything should become green because what I have offline and what I have online should then be the same. And we'll see how this works. Good, so everything is the same. Now we can go online and see and monitor the blocks. I'll also monitor this one. What's going on? Okay, so now we are online and this process is waiting for this switch to come on, the automatic switch. We can do all of that in our simulation table, which we might need to set up separately, but this video is becoming quite long and I don't want it to be very long for you. So what I'll do here is I can set this to true, right click, modify. Let me do that on maybe on the tag table if I have it defined already. So I've gone ahead to create a simulation view. I've also inserted all our inputs and outputs. I'm also monitoring the block on OB1. You can see OB1 is calling the block, it's green. That when we go inside the block, we see this view. We're waiting for S3 to come on. So this is S3. In this case, S3 is what? Auto switch. So if I click on this to turn S switch to on, yes, now S switch is on, S3 is on. These are auto switch. And when we say, when the Ottoman gets home, S1 sees Ottoman, which is the outside door, and then it opens up K1. So I'll switch on this outside sensor and we'll see what happens to the door. So we'll switch this on, and then it sets the switch on. So the door relay is on. However, we say when the guy goes in, this outside door no longer sees him. So I'll remove the outside sensor, which is this, to switch it off. But you can see the door stays open, which is correct, right? He has moved out of the door has opened. He moved under the sensor, the door opened. Now he's gone away from the outside sensor. So he moved to this sensor, the door opened. He moved here, he's away from the sensor now, so he's going in. But the door stays open, which is why we used the set. If we use just a coil, immediately we turn this off, the coil goes off, which means if he is in front of the door, then the door will close on him, which is not what we want. So we want this sensor to open the door. Now the door is open. The sensor is off. He's inside the house now, right? Now we want to switch on the sensor inside the house, which is S2 in this case. So we switch on S2, and S2 then resets the system. And when S2 is on, you see it's counting the timing, 3 seconds now. It's counting, and then after 5 seconds, it switches on the door light. I hope you're able to get that. We can do that all over. I'll switch off the auto again, switch off everything, right? Everything is off. So Mr. Orange comes home, he switches on the auto switch, boom. The auto switch comes on and everything is waiting. The sensors are waiting, both sensors are waiting, S1, S2. It goes under the S1 outside sensor, and when it goes under that, the outside sensor comes on, which opens up the door. It moves away from under the sensor goes off, right? But the door stays open, which is correct. So it goes in through the door. When it goes in through the door, it gets under sensor, indoor sensor, and then indoor sensor comes on, closes the door and starts the counter. It's counting the time up until 5 seconds, and then it switches on the light. So that's what we wanted to achieve with this. What we can do next is to create a sequence. We can create a sequence for this. The way we've explained it now, we can create a sequence with the timing. We also did the training on this. So maybe in our next video, we'll do that. Thank you very much and see you in the next video. Before that, what I'd also like you to do is to do an SCL code for this. Basically, what you can do is you can just take a screenshot of this project, which I'll upload under this video, and you can put it on maybe ChatGPT or whatever to give you an SCL code. And then you try to run it, you try to understand it, to try to see how it works. You see how the interface of the block looks now outside the block in itself. Okay, take care.